Alrighty, let's get going here. Today we're going to be taking a look at section 7.2, surface area of prisms. We've already dealt with one type of prism, a rectangular prism, or a box. So let's just quickly recap what that is. So we've learned that a box has three dimensions. It has a length, a width, and a height. And so we calculated the surface area of this rectangular prism by calculating the area of the front and the back, the top and the bottom, the left and the right side. Well, another way we can look at it is that we can find the area of the front, so that's the length times the height. We have the area of the top, which is the length times the width, and we have the area of a side, which is the width times the height. Now, each of these we need to double, but rather than doubling it right here, what we can do is we can just add these up first and then double the whole thing. That's the same as doubling each one of these quantities before you add them. And this is actually a formula for calculating the surface area of a rectangular prism. So rather than breaking down the front, the back, the left, the right, top, and the bottom, you could just plug everything into this formula. Now, what makes this a prism? A prism is made up of a two-dimensional object that is then given that third dimension height to create a 3D object. So a rectangular prism starts off with a rectangle. So imagine a rectangle being flat on the ground. And then we stacked more and more of those rectangles on top of it until it was tall enough to look like this diagram, where we've given it that third dimension, that height. Let's try another type of prism. A triangular prism will start off with, you guessed it, a triangle on the bottom. So I'm going to start with a triangle on the bottom. And if you imagine we took this flat triangle and then stacked a whole bunch of them on top of one another, we would end up with a tower of triangles. And this tower of triangles gives us this triangular prism shape. You've actually seen these before. If you've ever been to a grocery store and seen like a Toblerone box, this is the triangular prism in real life. So we're used to seeing this tipped on its side, so let's draw our triangular prism tipped on its side. So it looks something like this, kind of like a tent. Now, to find the surface area of a triangular prism, we actually use the same strategy as the rectangular prism before we had the formula. What we do is we find the area of every single surface on our prism. Let's dive into an example and see how that works. So let's find the surface area of this triangular prism right here. So we have this triangular prism. It is going to have a height of 4 centimeters. So that's the height of this triangle at the front. It's an isosceles triangle. So these sides of the triangle are both 5 centimeters, and the bottom side is 6 centimeters. Now, the depth of this prism, or if it was tipped and standing up, the height would be 8 centimeters here. Let's go through and calculate the area of each of these surfaces. We'll start with the front. Now you'll notice that the front is a triangle, but there's also a back, which is also a triangle, so we're going to include those together. So the front and back we can calculate at the same time. Now these are two triangles, and remember that the area of a triangle is its base times its height divided by 2. Now in our case, our triangle has a base of 6 centimeters. And it has a height of 4 centimeters. And then we divide it by 2. So that's the area of one triangle. Now, since we're calculating the area of not only the front triangle, but also the back triangle, we'd want to multiply this by 2. So we end up with 24 squared centimeters. So that's the area of the front and back triangle. All right, let's move on to the next section. Let's take a look at the other surfaces on this triangular prism. We have this one here on the right side. And then there's another one on the left side. And then there's another one on the bottom. Don't be fooled. These 3 rectangles are not all the same size. If you take a look at the one on the right, it has a length of 8 centimeters and a height of 5 centimeters. If you were to consider the surface on the left side, it has a length of 8 centimeters and a height of 5 centimeters. So those two are the same, but if you were to consider the surface on the bottom, it has a length of 8 centimeters and a width of 6 centimeters. So the bottom one is different. Let's tackle the left and the right surface first. So this is just a rectangle. That's simple enough. To calculate the area of a rectangle, you simply take its length times its width. And because there's 2 of them, we will double this. We'll end up with 80 square centimeters. Oops. There we go. Now let's do the bottom piece. So the bottom piece had a length of 8, a width of 6, and there's only one of them. So we're done here. This is 48 squared centimeters. So the takeaway from this is to double check your triangular prism. These rectangles are not necessarily all the same size, so please don't just take the length and width of one of them and then triple that area. That's not going to work out for you. So you have to double check the dimensions of each of those rectangles. All right, now that we have the surface, the area of each of these surfaces, we can now calculate the surface area. So the surface area is just the sum of these numbers. So 24 plus 80 plus 48 And so surface area is 152 square centimeters. There you go. So to find the surface area of a triangular prism, we actually use the exact same tactic that we learned last time. We calculate the area of each of the surfaces, then just add them up together. The next prism we're going to take a look at is a circular prism, or we call it a cylinder. So a cylinder looks like this. So a cylinder has a circle on top, there's a circle on the bottom, and then there's a side panel that's kind of wrapped around that circle. To better understand how to calculate the surface area of a cylinder, we need to take a look at what happens to a cylinder if we were to unravel it and flatten it out. So over here, we have a cylinder. Now, we already mentioned that the top and the bottom are just circles. So let's go ahead and pop those off. So there's a top circle. Now this middle section, if we were to cut down one side, perfectly straight cut, and unravel it, you will see that it is just a rectangle. Here, well, let's fold that down. So we have two circles and a rectangle. Now the width of this rectangle was the original height of our cylinder. As for the length, well, remember that it was wrapped around those circles. So the circumference, or the perimeter of the circle, will match the length of our rectangle. So let's go back and take a look at our notes here. We can now see that our cylinder can be unraveled into a circle, a rectangle, and another circle. Now, to calculate the area of a circle, we would need its radius. So we would need the radius. We would also need the measurement of the cylinder's height, which then turns into our rectangle's width. And then to find the length of our rectangle, we would need the circumference of our circle. And this is stuff that we should already know. The area of a circle is pi times r squared, where r is our radius. The circumference of a circle is 2 times pi times r, which is our radius. So keep these formulas in mind as we break down how to calculate the surface area of our cylinder. So the surface area of a cylinder is, well, it's the area of each of our surfaces. The first surface we're going to take a look at are the circles. We have these two circles which have an area of pi r squared, and there's two of them. So we're going to take that and we're going to double it. So these are our two circles. Next, we have this rectangular shape. from the side that was cut and then unfolded? Well, the area of a rectangle is the length times its width. The length is the same as the circumference of our circle, so 2 pi r. So that's our length. And then we need to multiply it by the width of our rectangle. In this case, it's h, or the original height of our cylinder. So this is the area of that one rectangle. And together, that is the surface area formula for a cylinder. It's 2 pi r squared plus 2 pi r h. Let's go ahead and see this formula in action. Okay, let's find the surface area of this shape to the nearest hundredth of a centimeter, which means 2 decimal places. It's a cylinder. This is 8 centimeters, and this will be 10 centimeters. Okay, let's take a look at our measurements and make sure we have everything that we need. In order to calculate the surface area of a cylinder, we need the radius and we need the height. What we have here for 8 centimeters is not the radius. If you take a look at the diagram, it actually stretches from one edge of the circle all the way to the other. That's not the radius. That's the diameter. So our radius is going to be half of that. So our radius is actually going to be 4 centimeters. Our height is indeed 10 centimeters, so that's fine. We can now take this and plug it into our surface area formula. So we have 2 pi r squared plus 2 pi r h. And let's plug in the numbers. 2 pi, our r is 4. We want that to be squared. And here we have 2 pi. Our r is 4, and our h is 10. Now, you may be tempted to reach for a calculator and punch all this in right away. I would hold off on that. There's actually a way for us to kind of clean this up a little bit before we jump into a calculator. This is all multiplication. 2 times pi times 4 times 4 again. We can actually rearrange these pieces and multiply the numbers together first and leave pi for later. So 4 squared, or 4 times 4, is 16. 16 times 2 is 32. So this is going to end up with 32 times pi. Okay, and we'll multiply by pi later on. Let's take a look at the next one. We have a 2, we have a 4, and we have a 10. Let's multiply these together. So 4 times 10 is 40. 40 times 2 is 80, and we're not going to multiply by pi just yet. We're just going to write it here that we need to do 80 times pi, and then these two pieces are being added together. Now, we can actually further simplify this. So just like we had in algebra when we had to combine like terms, this is the same idea. I have 32 pi plus 80 pi. I can actually combine this together to give me 112 pi. And so this is the most accurate representation of our surface area. If we then wanted to calculate our surface area as a decimal number, we'd have to do some rounding, but we would end up with a number that is an approximation. So if you punch this into a calculator, you would end up with 351.858,377, and it keeps on going. The answer is supposed to be with 2 decimal places. So we want to round it off right here. We want to cut it off right here. So we're going to take a peek at this number here to determine if we need to round up or not. That number is an 8, which is greater than or equal to 5. So we are going to round this up to 351.86 square centimeters. So there are going to be times where I want the most exact answer possible, and that's where you can leave it in this form. But if the question did specify that I do want this to be a decimal number, and I've specified how many decimal places I want, then you can go ahead and round it and give me this answer here. All right, that's it for today. Thanks for tuning in. I'll see you next time.